All right, so back to this. Now, for this problem right here, it says the coordinates of the vertices, the quadrilateral A, B, C, D, are there. How long is each side of the quadrilateral? Show your work. Now, for this, let's go ahead and start by putting in my values. Okay, I'm going to put these where they go. You guys, actually, your graph is probably a little bit better than mine. I couldn't blow mine up any bigger. I tried to. It got blurry. So let's see. So for this, we have 1, 5. 1, 2, 3, 4, 5 right there. 2, 2, 2, 2. We have -2, 0. And we have -3, 3. There we go. That's D. -3, 3. -2, 0. C. There's B. 1, 2, 3, 4, 5. There's my A. Connect my dots. All right, so how long is each side? So now, if I'm asking for how long, what am I actually looking for? Distance, right? Not slope. Look for distance. Okay? I'm looking for the distance, so I need to use distance formula. So I'm gonna show you guys how to do this again. So we know that the distance is equal to the square root of delta x squared plus delta y squared. Okay, so we're going to start for the distance of each side. So let's start with A to B. So A, AB. So that's going to give me square root of, now since I have this on my graph, okay, I have this on my graph, we're going to count using my delta to see how far they're apart. So for delta x, so from A to B, how far is 1 from 2? 1. So I have 1 squared plus. How far is 5 from 2? 3. So that's going to give me AB is square root of 1 and 9, 10. There we go. Yes? Yeah. Okay, so let's keep going, right? So the next one's going to be BC. So BC, how far is 2 away from -2? 4, very good. How far is 2 away from 0? 2. So that's going to give me square root of 16 plus 4? 20. Okay. Next one's going to be CD. So for CD, how far is -2 away from -3?
1.
It's 1, right? -2 is 1 away from -3. So there's 1 squared. And so for that one, so how far is 0 away from 3?
3.
Squared. So that's going to give me square root of. So 1 and 9 is 10. Very good. And my last one is going to be what? AD, right? AD. So AD. Okay, so from A to D, how far is 1 away from -3?
4. Oh.
That's 4. That is 4. Okay, so 4 squared plus how far is 5 away from 3? 2 squared. So that gives me 16 and 4. 20. There we go. So this is all the work you got to show for this. So I started off with the formula right here. Started off with the formula, worked it out. Okay. So if you want to get full points, you have to get all the work for this one, okay? Now, what are the slopes of each side of the quadrilateral? Okay, slopes. Slope formula. Now, I'm going to do this slightly different than what I did before. So, because I feel like it. Okay, because it's easier to count. If I have a graph, I could count. Okay, so we know that slope is rise over run. Slope is rise over run. Okay, now run is always to the right. My rise is either up or down. So let's take a look at AB. So now from right here, I'm going to count. So I'm going from here like that. Drawing a little triangle like that. So my rise, isn't the rise going down from here? Because I always read from left to right. It's going down. How many is it going down? 1, 2, 3. So it's down 3. And to the right, how many? Is it 2 or 1? 1. Looks like 1. It is 1. So negative 3 over 1. Okay. All right, let's do the same thing. Let's do it on the other side over here. So let's go this way. That way there. So they're doing DC. So from DC, again, I'm reading left to right, and it's going down. How much is it going down? It's so negative 3, and how many over? 1. Over 1. So it's negative 3 over 1. Very good. Now let's do the other way. Okay, so now we're going from D to A. So D to A. So it's going to go up this time and over. Up and over. So DA. Now, it's going up. How much is it going up?
2.
It's going up to
4 over.
and over 4?
Yeah.
Does 2 over 4 reduce?
Yeah.
It reduces to what? 1/2. Very good. 1/2. There we go. All right, let's do the other side. CB, right? So CB, it goes up. How much does it go up? It looks like 1, 2. Yes, it goes up 2. And it goes over 4. Okay. Which again gives me 1/2. Very good. So, now, looking at this much information right here, what do I know about AB and DC? It's not congruent. Okay, they're parallel. Because we're talking about slopes now, right? We're talking about slopes. So slopes, if they're the same, they're parallel. What about DA and CB?
They're the same.
They're the same, so that means that these two are parallel. So in your handy dandy notebook, please make sure you actually write it down about, there's actually a vocabulary word for parallel there. So in your handy dandy, you're going to make sure that you have the information for that, okay? Yes, I do. Okay, because we're talking about parallel and perpendicular, right? If you're looking in the handy dandy, you actually have a little spot right there that's asking about parallel and perpendicular, but it was blank. I left it blank because I wanted you guys to fill in what we did from the notes. So parallel lines have what?
Have the same slope.
Very good. Okay, and we'd have to go back to a different one to figure out the perpendicular lines.
Wasn't it on one of the pages we did?
Yeah, we did it yesterday. It was on one of our things yesterday. Perpendicular what?
Perpendicular lines are reciprocal, something like that, right?
Opposite and reciprocal. We did it on this one right here. So perpendicular were opposite and reciprocal. Okay, so let's see. What type of quadrilateral is this, and explain your reasoning. Okay, so let's take a look at the information I know. Okay, so you guys are looking through the checklist now, right?
Yeah.
Okay, you're looking through the checklist. Okay, so on your checklist, or all your things, so you're actually figuring out. So first, okay, we're going to start at the top of that flow chart, and we're going to work our way down. Is this a quadrilateral?
Yes.
Why is it a quadrilateral?
Because all of them are quadrilateral.
What makes it a quadrilateral, though?
Have one.
4 sides.
4 sides. Does it have 4 sides?
Yes.
Okay, very good. So it has 4 sides. So it is a quadrilateral. Okay, let's move down. What's after quadrilateral?
2 pairs of parallel sides.
2 pairs of parallel sides, which is going to be what shape?
A parallelogram.
Parallelogram. Let's look.
Okay.
Does it have 2 pairs of parallel sides?
Yes.
So this is also a parallelogram, isn't it? Okay, what else do we know about parallelogram? Some about opposite sides.
Opposite sides are parallel and congruent.
And congruent. Parallel and congruent. Okay, our opposite sides, let's take a look. We have, let me grab a different color real here. Okay, so this and this, those are opposite of each other. And they're congruent, right? Okay, so let's look at the next one. So we say that AD and BC are opposite each other and congruent. So opposite sides are congruent, very good. And opposite sides are also parallel, aren't they? Okay, so very good. So we have that. So we have parallelogram, right? Okay, so what else do we have? What else can we figure out from this right here? So far we have that it is a parallelogram. What's down below a parallelogram? A rectangle. Give me a property of a rectangle that I could check here.
4 right angles.
4 right angles? We could check for right angles. We could check that, right? Okay, so now let's look at the slopes to figure out if it has right angles. Okay, here's the slopes right here. So these 2 slopes, we're comparing this. The slopes have to do perpendicular. So if it's perpendicular, then it means that the slopes have to be opposite and reciprocal. Are they opposite of each other?
No.
They are opposite. They are opposite. Look, see this right here? This is a negative, and this one here is a positive, right? That's what it means by opposite. These 2 are opposite signs.
Oh, reciprocal means flip, huh?
Yes, reciprocal means flip. So, are they reciprocal now?
No.
No, they are not opposite and reciprocal, right? So, it is not a rectangle. This is not going to be a rectangle. Okay, so it is not a rectangle. So we already know that. So it's not a rectangle. Okay, what's the next thing? I know it after parallelogram it branches into 2 things, right? Rhombus. Okay, if it was a rhombus, what is a thing in a rhombus that is special about a rhombus?
All the sides are congruent.
All 4 congruent sides, right? Do I have 4 congruent sides here?
No.
No, I don't. I only have 2 pairs congruent sides. So all 4 are not the same. So this is not a rhombus also.
So wouldn't that mean it's just a parallelogram?
Yes.
Because it can't be a
RHOMBUS. All right. So this has to be a parallelogram. So this one has to be a parallelogram because all those things I stated, we had opposite sides. Are parallel. Are congruent. So opposite sides are parallel, opposite sides are congruent. So that gave me that it has to be a parallelogram. I have the reasoning here. I did all the thing to prove that it's not a rectangle. And we also said it's not a rhombus because it doesn't have 4 congruent sides. It's not a rectangle because it does not have right angles. Okay, the slopes are not opposite reciprocal. So if you want to throw all that extra stuff in there too, you can. Make sure you get all those points for this question. All right.
Mr. Consecutive means like right next to each other?
Yes, next to each other. So it would be, so for a consecutive, let me show you back on this.
Like consecutive angles?
Okay, yeah, consecutive angles would be like a BD on this one or a CD. That's what it is. Okay? All right, also, I made a mistake yesterday. And I wanted to correct that. You guys are going to fix this one right here. Statement 4. Statement 4. Yesterday, I don't know what happened, but I got corrected by my 6-hour class. So, on statement 4. Statement 4, because it was a square, right? We looked at the flow chart, and since we proved it's a square, right here we proved it's a square. Since we proved it's a square, now everything goes up. If you're looking at the flow chart, if it goes up, it is always. If it goes down, it's different branch. It's going to be never. So since I proved it's a square, which is all the way on the bottom, it had to be everything going up. And directly up from a square is a rhombus. So that means that it had to be. So this one was a true. So I'm sorry I messed that up yesterday. If you guys go ahead and fix that. Because all squares are rhombuses. Rhombus. Rumble. Rumbi? Rumbi.
Rhombus.
Harumbas. Harumbus.
Rhombuses.
Harumbuses?
Rhombi.
So multiple gorillas are
Gorilla.
harumbuses. Gorilli? Gorillies? Okay. Alright, so anyway, alright, let's take a look at, this is our last one here. Okay, so on this one right here, prove that the quadrilateral shown below is not a square either through slopes or length. Through slopes or length. Now, the easiest thing to actually do is look at our diagonals. In a square, what do we know about the diagonals? They're congruent. Okay. So now, this one's so easy. It's almost like cheating. It's easy. All right. This diagonal from here to here. Is that on the line?
Yeah.
If it's on the line, what could I do to figure it out? Count it, right? So what is XZ? It's how much? 1, 2, 3, 4, 5, 6. And YW? One, 2, 3, 4, 5, 6, 7. Uh-oh. So what does that mean? They're not congruent, right? The diagonals are not congruent. So this is
Not a square.
not a square. All right, that was super easy. Okay, so now let's actually do the rest of the work just in case, because it's not going to be that easy on the test. So yeah, so I'm going to go through and put in my points. So this point right here is going to be 1, -1. This one over here, let me see, 1, 2, 3, 4, 1, 2, 3. This one's going to be 4, -1, 2, 3, 4. This one is 1, 2, 3, 4, 5, 6,
That's
7.
-4, the one you said?
Yeah. So let's do the distances. Okay? I showed you guys how to do distance on that previous problem, which is actually pretty easy. So we're going to do distance. So let's see. X, Y. What is my delta x for xy? It's 3 squared. What is my delta y?
4.
So that's going to be 9, 16, square root of 25, right? What is square root of 25?
5.
There we go. All right, let's do yz. Okay, so how far is it from 4 to 7? 3 squared plus, how far is it from 3 to -1?
4.
Equals, that's, okay, it's 5 again. Okay, let's do WZ. How far is it from 4 to 7? 3, very good. How far is it from -4 to -1? 3. So let's see, that's going to be 9 and 9, that's square root of 18, right?
Oh.
So 9 plus 9, yeah, square root of 18. And then my next one is WX. So WX right here. How far is it from 1 to 4?
3.
3. How far is it from -1 to -4? 3. Square root of 18. So, for this thing to be a square, what has to happen?
They all have to be equal.
Are they all equal?
No.
So we know it's not a square. But now, can you tell me what this would be?
Rectangle.
It is not a rectangle.
What?
Because in a rectangle, opposite sides are the same.
It doesn't look like a rectangle, but
It is not.
it looks like. But I was like looking at the map.
Look at your chart.
It's a rhombus.
Quadrilateral.
It is not a rhombus.
It's a quadrilateral. Kite.
It is a kite. Very good.
Oh,
It is a kite because rhombi have all 4 sides the same. Rhombuses. Hey, listen up. Listen up. I'm almost done here. Listen. Excuse me. Hey, I know you're excited to be done with this, but come on. Okay, so this is going to be a kite. Because if you guys are looking at your thing in your kite, these two right here are congruent, and these two here are congruent. So if I were to put my tick marks, that's congruent to that. That one is congruent to that one. So if you go through and look at your chart on kites, it's going to look something like this. All right, there we go. Now I'm done.